In this lecture, we are going to talk about the main differences between stack memory and heap memory. So let's talk about heap and stack memory overview. So knowing how memory actually works in Java is important as it gives you the advantage of writing high performance and optimized applications. It helps you to understand the scope of variables, object creation, and memory management in the main. In Java, there are two main memory types, stack memory and heap memory. As far as stack memory is concerned, it contains method calls, local variables, and reference variables. On the other hand, heap memory contains objects and instance variables. You may pose the question that what are instance variables? For example, when we have a car class, then we can define private integer, for example, speed. We can define private string name of owner and something like this. So these variables that belongs to the class itself, these are called instance variables, and these variables are stored on the heap memory, of course, because these are associated with the object itself. Okay, so stack memory contains primitive values that are specific to a method and references to objects that are in a heap referred from this given method. The Java heap space is used by Java runtime to allocate memory to objects and Java runtime environment related classes. Whenever we create any object, it is always created in the heap space. Okay, so let's take a look at a concrete example. Every single application starts with the main method. Because it is a method call, it's going to be inserted into the stack memory automatically. So in the stack, a frame will be created from the main method. And if we create a given variable, for example a double with value 10, then this local variable d in the main method will also be created in the main method's frame on the stack memory. So that's why the main method has a local variable d. If we make a given method call, then this public void method1 will be called with the given argument. So what does it mean? Method calls are stored on the stack memory, so there's going to be another stack frame for method 1. Okay, so if we create the method 1 specific local variable, a floating point number with value 30, then these values are going to be stored on the stack memory associated with the given method. So method 1 stack frame is going to contain the argument I and the local variable f. So as you can see, every single method has a distinct frame on the stack memory. And by the way, these stack frames are independent. So for example, within the main method, we are not able to alter the value of the local variable f because they are in different stack frames. Anyways, if we call, for example, another method, method 2, which is a public void method again, it is going to be stored on the stack as usual. And if we create a new object, for example, we have a class house with instance variables, windows and doors. If we instantiate a new object with the new keyword, then this house object is going to be stored on the heap memory. Okay, so as you can see, a new object is created on the heap memory with instance variables. So it is crucial that instance variables, it may seem to be very similar to local variables, but they belong to a given class. So local variables are stored on the stack, but instance variables that belongs to a given class, they are stored on the heap memory. And the reference itself, in this case the house ref, is going to be present on the stack memory. Okay, so as you can see, the house reference is on the stack memory. This is what we have been talking about in the previous lecture, that the reference itself is on the stack memory, but the object it is referencing is present on the heap. Okay, so the assignment operator makes the house reference variable to point to the house object in the heap memory. Okay, so there's the reference from the house ref present on the stack to an object present on the heap memory. So what's going to happen when we finish with method 2? When method 2 execution is completed, the flow of the control will go back to the command method 1, because method 1 called method 2. That's why Java is going to consider method 1 again. Okay, so this is what's happening here. And what's crucial, that because method 2 is completed, it is flushed out from the stack. So this method 2 related stack frame is going to be removed from the stack. So what does it mean exactly? That there is no active reference to the object present on the heap. So what does it mean exactly? That this object is eligible for garbage collection. So when the Java virtual machine runs the garbage collector, the object will be destroyed because there is no active reference to that given object. This is exactly how garbage collection works. After method 1 is finished with its execution, then method 1 stack frame is going to be removed from the stack memory, and the flow control will go back to the command main method. So this is why this stack frame is removed from the stack memory and we go back to the main method. And because there are no more operations in the main method, which means that we are finished with the execution of the main method related stack frame is going to be removed from the stack as well. Okay, so this is how stack memory and heap memory works. Method calls, arguments, and local variables are stored on the stack memory, but objects on the other hand are stored on the heap memory. So whenever we create a new object, then the reference itself is on the stack memory and the object itself is on the heap memory. So this is the crucial difference between stack and heap. Okay, so any object created in the heap space has global access and can be referenced from anywhere of the application. The stack memory is always referenced in a LIFO, so last in first out order. Push operation adds an element at the top of the stack and the pop operation removes an element from the top of the stack. So I'm not sure whether you are familiar with abstract data types and data structures, but stack is the most common abstract data type. We can store items in a LIFO manner, so the last item we insert is the first one we take out. In this case, the stack is going to contain method frames, and within the method frames there are local variables and argument values. Okay, we can use Java Virtual Machine options to define the startup size and the maximum size of the heap memory and the stack memory. So we can control that what's going to be the size of the stack memory and the heap memory. What's crucial that when stack memory is full, then Java runtime throws a stack overflow error, whereas if heap memory is full, it's going to throw an out of memory error. So this is crucial as a software engineer to be able to detect whether the stack memory is full or the heap memory is full, and we can conclude based on the error itself. Stack overflow error has something to do with the stack, and out of memory error has something to do with the heap memory. In the next lecture, we are going to talk about how to monitor heap memory in Java. Thanks for watching.